Okay. Okay, so here I am going to talk about some discrete structures. In discrete structures, I am going to only focus on set and function, which is something more important for the data science people. And I'm going to elaborate in detail linear algebra, right? I think we come across with come across with this particular concept from our schooling, right? So there, I think you people have studied vector space, vector algebra, and in specific matrix algebra, right? That is the thing I'm going to cover. So if you know the various operations and math behind the matrix, then you can do wonders in data science. Okay, and most important thing is statistics. So without statistics, I think it's not possible to build a career related to data science, and at the same time probability. And if you are going to pursue a research like that, surely before going to proceed your research, you have to frame the hypothesis. So if it is in your research, you are going to have several features. And if you are going to find the relationship or association between the features, for that you have to do some hypothesis testing. How one variable is associated with other variable. That is very, very important in a research. Either it may be a social science research or a scientific research. So setting the hypothesis and testing the hypothesis is something more important. So now here I'm going to explain, there are several techniques out there, but here I'm going to explore chi-square text for you. So this is the overall outline of my talk for another 90 plus 90 minutes. Okay. So let us ask this first question. Why I have to choose the career in data science? And why specifically nowadays all people are talking about data science? Especially, I can say data analytics. Because data, we are having an enormous amount of data. So we are living in a digital world. Even in a second, we are getting a terabyte or petabyte or exabyte of data, right? So and all this lot of data is being collected and warehoused, right? From several applications. Either it may be a web data, from e-commerce, we are getting enormous amount of data. So if you are going to take a financial transaction, right? Enormous amount of data are going to be generated, right? So that is the purpose, right? Most of the people are dwelling into data science career, right? I think now I answered this question, why people are moving towards data science. And next, what type of data they are handling, right? Whatever may be the applications, the data may be classified in this way, right? So, but if I'm going to ask about, what about data to a mathematician, he or she will tell a data may be a discrete data or continuous data for a mathematician point of view. If I'm going to ask this question, what is data to a physicist? He or she may say a data may be analog data or digital data. But if I'm going to ask the same question to a computer science professional, right? We people can say a data may be a structured data or semi-structured data or unstructured data, right? So with this structured, unstructured, semi-structured data, I categorize the content. So the relational data that is so far we have discussed, right? From our schoolings, right? So data which is organized in terms of tables, that is rows and columns, right? That is one example of a structured data. And text data, right? Usually a running text, right? So this is called unstructured data, right? And the next one is semi-structured data, a data in form of XML format, right? So I think everyone knows about XML, right? So some part of data, it would be text data, and some part of the data maybe in terms of tags. So it is called semi-structured data. Apart from that, there are some data called graph data is there, and streaming data. Nowadays, IoT applications are coming up like anything, right? Okay. So that kind of data we can categorize as a streaming data. So altogether, the data may be a structured or semi-structured or unstructured. With this particular data only, we are going to do our analytics. Especially the data science will more specifically targeted with these three groups of data: structured, unstructured, and semi-structured. So depending upon your interest, depending upon your application, you can focus your career. Either it may be on structured data or unstructured data or semi-structured data. But 60% of now data science works are done only on unstructured data, and remaining things with respect to structured and semi-structured. Okay. Yes. Ultimately, what we are going to do with this data, right? We are going to do some aggregation operation, that's all. And we are going to apply some statistical tools and models, right? If I'm going to do some aggregation and statistical models on a warehoused data, that operation is called as OLAP, that is online analytical processing. I think you come across these kind of things in data mining course, right? So the other major operation that we are going to do with this data is indexing. I think most of you know the concept of indexing. And at the same time, if we are having a data, we have to search for the data. And if the data is there, I have to retrieve the data through by means of writing some queries, right? And apart from that, we have to discover the knowledge from the data. This is the core idea about data analytics. Otherwise, I can say data science. So a data science, we are not going to do only aggregations or applying statistical models. We are not only going to do indexing, searching, or querying. Apart from that, I'm going to find out some interesting patterns. That is called knowledge discovery. So that is the major focus of data science. For that, we are going to use machine learning algorithm and deep learning algorithm. For what? Knowledge discovery. So that is all things I'm going to do with a data. Everyone going to do with data. So with these assumptions and with this prerequisites things, I can define data science like this. Some theories and techniques from many fields, not only mathematics, even you can apply some of the concepts of physics, right? And you can develop a model, right? For a data science applications. Yes, it is possible, right? So whatever may be the application area, so you are going to take some theories and techniques and you are going to do some kind of an investigation and you are going to analyze on large amount of data, depending upon our application. If your data is small, don't worry, right? If your application is restricted to a small amount of data, you please apply the models and get the result and find out the interesting pattern. It is not always necessary to have a very large amount of data. It is up to the application. And finally, what we are going to do, we are going to give the knowledge to the decision makers. That is the person who needs the knowledge. So that is actually data science from my interpretation. And at the same time, why nowadays it is so popular? So if you want to check the popularity of any particular technology with respect to computer science or any field, I think I will rely only on Gartner hype cycle. So every year, the Gartner hype cycle will be released with respect to each application domains, right? If you see the Gartner hype cycle for the past 5 years, you can find the role of data analytics. You can find the role of data science in the slope of entitlement. So that's why I am saying, surely if you are going to focus your career, if you are a student, right? If you are going to focus your career towards data science, surely you are having a wonderful future. At the same time, for the faculty members who are present in the session, right? Surely you are going to do some kind of, if you are going to build some model, statistical model or any model related to any particular field, to any particular data, then surely the research community will recognize you, right? So because of this Gartner hype cycle only, I'm saying all these things. It is not my assumption. I think now you understand. So a data science is a very nice area. Being a student or a faculty, so we can explore this particular thing and we can come up with a lot of laurels. Okay. So if you really want to do some kind of good things with respect to data science, surely mathematics and some level of applied mathematics is needed and statistics is needed, right? So once if you are strong in these three things, then only it is able to go level by level in data science. Otherwise, it is very tough. If you are a student, my dear, I am once again emphasizing, without mathematics, it's not possible to do some higher order analysis in data science. Yes. So that is the purpose. I think Kumar sir scheduled this particular session. I think 2 sessions he has given to me. Thanks for that. Right? Surely I will do some kind of justice, right? If you are forgotten some of the basic mathematics, right? Surely the session is going to be helpful for you to refresh all these kind of things. I am not going to explain you any rocket science, right? So I am going to explain you some basic fundamental of mathematics that is to be applied on a data, right? For finding out the knowledge, for finding out the interesting pattern, for finding out the hidden patterns. How this mathematics helps us. That is a thing I am going to cover for another 90 minutes of time. Okay, fine. So apart from this mathematics, if you want to focus your career, surely you have to be strong in any one of these programming language, right? Either Python or Julia or SQL. But most of the trend is right. So most of the people are using Python only because availability of library, because it's a very good forum, right? So lot of libraries are created in Python. So I think, right, if you are new, so please concentrate on Python. And if you are very strong in R, don't worry. Yes, we can do a lot of wonders, right? In R also, right? And at the same time, there is a possibility to integrate R and Python also, right? So if you're going to choose R and Python, then surely you are having a better future. So I'm talking all these things for students' perspectives, right? So I think if it is a data science, the people will talk about these three areas: data mining, machine learning, deep learning, and at the same time statistics also, right? So after completing this session, this FDP, I think you clearly know what is data mining, what is machine learning, and what is deep learning. And when we have to use data mining, and when you have to use machine learning, and when you have to use deep learning, right? So it is not necessary to apply for all problems, to solve all problems, deep learning, not necessary. So it is all what kind of data you are having. That is most important. So if the data is small and if the number of features are restricted, and if you clearly rely on the goodness of the feature, then machine learning is enough. Machine learning is enough to find the knowledge, right? Right? When there is no need to do any kind of feature engineering, then automatically the machine learning algorithms like decision tree algorithm, random forest algorithm, Naive Bayes algorithm, KNN algorithm, all these algorithms, right? All these algorithms will having some mathematical stuff, right? So will give you wonderful result, right? But there are some situation, there are some application for which the user is unable to find out the future. Then only you have to go for what? Deep learning, all right? I think R is missing here. Sorry for that. Okay, fine. So that's all my introduction about the data science. I think you had all these kind of things and yesterday also, but I have said according to my point of view. Now I am going to my own business, right? That is mathematical foundation for data science. First, for another 15 minutes of time, I am going to discuss about the mathematics related to sets and functions. I think you come across with these concepts from in your 10th standard, I can say, and even from 11th standard, I can say. But I think most of you forgot all these concepts. But these concepts are very, very essential for a data science professionals. Okay, so I'm going to touch upon all these kind of things for another 15 minutes. Kumar sir, can I proceed? Whether I'm audible?
Yes, sir. Audible.
Yes, sir.
Thank you. Thank you. So now and then I will check because I'm not seeing your face, right? That's why. So I request all the participant for another 60 to not 60, 70 minutes. Please give your attention. Surely you will carry a lot of information, mathematical information, right? Okay. First, what is first of all a set? A set is an unordered collection of objects. Otherwise, they will say a well-defined collection of objects. That is called set. So that set is mathematically represented in two ways. One is Rosen method, another one is set builder form. In Rosen method, you can see all the elements of the sets. See here. Here I named the set with the name V. So this V is the name of the set. And these are all the elements of the sets. So usually the set is represented by means of the flower brackets. So here V is a set and it consists of 5 elements: A, E, I, O, U. Order doesn't makes a major role in writing the set, right? E, I, O, U. Again, it consists of 5 sets, right? That's why it says unordered collection of objects. It is easy, but it is not always to represent the set by using Rosen form. Because if there is a more number of elements are there, it's very difficult for us to write in this form, Rosen form. That's why there is a concept called set builder notation. So in the set, if you see any research papers related to data science, and if they are narrating the elements, because the data which comes from sets only, right? So they will use the set builder notations only, right? See here, the name of the set is A, and if you are seeing the elements by another variable X, and that variable is represented by means of the property P of X. So that is called set builder notation. So here A is the set of all element of X, and what is X? The X comes from the another set capital S, such that it satisfies the property P of X. So here the symbol such that, and this is an element symbol, right? So everything is represented by means of set bracket. So this is called set builder method. Let us take an example so that you will get some better idea. See here, I have written this particular set X equal to 2, 4, 6, 8, 10. This is a normal roster method. Now I want to represent this set X by means in set builder form, that is by means of property. Then after seeing these elements of the set, it is clearly visible that all the elements comes from integers. So it is Z. So what are all these things? I have to give some number, for X. So that I am mentioning it is N. So X equal to N, and all the elements, that is N, is an element of Z, that is integer, such that now I am going to define the property. What is the property? Just to see the elements. So the element starts from 2 and ends with 10. So that N should starts with 2 and less than 10. So N should be greater than or equal to 2 and less than or equal to 10. And most importantly, if you see all the elements are of even number in nature. So I am defining the property like this. So X equal to N, element of Z, such that N is even, and at the same time, N lies from 2 to 10. So this is the set builder notation of a given set. So a set can be either represented by roster method or by means of set builder form. That's all. See, now it is very, very essential. If you see any IEEE paper or any SEA index journal, if they want to represent the numbers, they will use this kind of notations, right? Each has its own area of research, right? I think we come across with all these numbers in our schoolings, right? N, everyone knows, set of all natural numbers. But there is a debate, right? The natural numbers, whether 0 is a natural number. Some people say the 0 is also a natural number. It's a point of what I have to debate, right? So if it is a natural number, that comes into a conclusion that it starts from 1 to, and it's infinite, right? And Z means, I already told that it's an integer, right? And Z plus means positive integer alone, right? If it is an integer, it's like a number line, 0, 1, 2, 3, 4, right hand side, left hand side, -1, -2, -3, like that, okay? So there are two things I can do. So set of all integers and set of all positive integer, set of all non-zero integer. That means what? Except 0, if I am going to write 1, 2, 3, 4 like that, then it is called Z star. And set of all even integers, 2, 4 like that. And all rational numbers. So rational number means a number which is represented in terms of fraction, A by B, right? So where A and B are integers, right? So there also Q star, that is set of all non-zero rational numbers. Q plus, set of all positive rational numbers, right? And real numbers. Real numbers means both rational and irrational, right? I think you know the meaning of irrational, that is square root of 2, right? That numbers are called irrational numbers. Similarly, the representation are R star, R plus. So apart from that, there is another kind of number. It's complex number. I think in data science, we will never use complex number, C and C star. But in data science, if you want to represent the data in mathematically, I think it is necessary for you people to go with all these representation. So from N, Z, Z plus, Z star, E, Q, Q star, Q plus, R, R star, R plus, right? So these are all the notations normally which comes under any kind of research papers while representing the data. Okay, now I'm coming with some properties of a set, right? So this is subset. So what is meant by subset? See, here with an example I will explain you. See here, X is a set, Y is a set, and Z is also, 3 sets are there. So when I can say Y is the subset of Z, If all the elements of Y belongs to Z, then I can say Y is the subset of Z by using this symbol. So this is the subset symbol operation. So now I am saying Y is not element of Z. Why? Because there is an element A which is not in Z. So I can say Y is not a subset of Z. Right? So it is very, very important for a data science. Say, for example, in a data science, if you are ultimately going to do some kind of an activity by taking some data, you will have several features, So one feature should not be a subset of another feature. If there is a subset is there, then it is both are same like that, right? So it should be identical. So that is the role of subset property. Okay, fine. So now I am coming to set equality, right? Set equality, if you want to define two sets are equal, if you do this kind of, if you satisfy these two properties, then you can say these sets are equal. Say, for example, there are two sets X and Y. When you will say the X and Y are equal, if you are going to prove X is a subset of Y and Y is also the subset of X, then automatically it is implicit that both the sets are equal, right? It's also a very, very important thing in data science, right? Again, to prove whether the two attributes are equal or not. For that, what you will do, you will first make one feature is a subset of another feature and do the reverse, right? If they are equal, then you will say the features are identical. No need to take that second feature, right? In this way. So the examples, 1, 2, 3, 2, 3, 1, both are equal, right? Both are subset. Similarly, I'm having X as a set and Y is a set. So X in roster form, that is red, blue, yellow, and Y is a set I define in a set builder form, C, such that C is a primary color. I think everyone know primary color, that is red, blue, yellow, right? So I can confirm X and Y are equal. So now I explain the concepts of subset and set equality. Similarly, there are other properties related to sets or finite and infinite sets. So when the number of elements in the sets are countable, then I can say it's a finite set. And if it is not countable, then I will say it's an infinite set. Usually, if you are going to focus your data in data science, so all features, if each features in your data set, it should be finite, right? But it may contain noise, it may contain some missing values, whatever may be the thing, it should be finite, right? So if you are going to handle some infinite set, it's not possible for to do some kind of an analytics. Okay. See some of the examples of finite and infinite sets. Y equal to 1, 2, 3 is a finite because it's countable. P equal to red, blue, yellow, 3 elements are there, it's finite. E, I mentioned only E, that is a set name, set of all even integer. So I don't know how many integers are there, even integers are there. So it's an infinite set. And pi is an empty set. It's a finite set with 0 elements, right? I think you people now understand what is the meaning of finite and infinite sets. And most importantly, the cardinality of a set. Cardinality means the number of elements in the sets. Say, for example, when a data set is given to you, right, they will ask how many features and how many rows. So how many rows, that is called cardinality with respect to your data set, right? So surely in a data science problem, you are going to work with the data set, right? So here, this cardinality of set gives the meaning of cardinality of your data set, right? So cardinality of a set means counting the number of elements in a set. Say, for example, P is a set having the elements red, blue, yellow. So what is the cardinality? The cardinality is 3. So the cardinality is represented by means of the symbol that is called modulus ABS, absolute value they will say. That is used for cardinality of set representation. And next most important thing is power set. So when a set is given, if you are going to write all these subset of that particular set, that is called power set, that is P of X. P of X is the set of all subset of X. With an example, I will clarify everything. See here, I'm having a set X, which consists of 3 elements, red, blue, and yellow. If you are asked to write the power set of X, that is P of X, then you have to write all the subset of this particular set. That is, first subset is pi, empty set. Next is red alone, blue alone. Next red and blue, and next red and yellow, and the next red and blue. Sorry, red, blue, yellow, everything. right? So there is a generalized formula is there. If the n elements are there, then 2 power n. See here, there are 3 elements are there. So the number of elements in the power set is 2 power n. That is 2 power 3, it's 8. So altogether 1, 2, 3, 4, 5, 6, 7, and 8. So 8 elements are there. Again, it is very, very important thing with respect to data science, right? That's all about power set. Next, I will discuss some of the operations that are involved in set, right? Usually the operation of the set, usually we can represent it by means of set builder form, or you can represent pictorially by means of a diagram that is called Venn diagram. So usually the Venn diagram is represented by means of a rectangle which has the outer area. It is called universal set, from where we are going to get all these numbers, right? And actually your set, right? That is represented by means of a circle. So here X is my set, right? So the elements of X comes from U only. Okay, that is the meaning of this particular Venn diagram. So if you take a real-time example, I can say, if you take any data set, right? So let us take an Irish data set. I think you know what are all the features are there in an Irish data set. It will have 4 features: sample width, sample length, and like that. Okay. So some value should be associated with each features. It comes from the universal set only. Each feature, sample width, sample length. These are all various sets, features, right? Which comes from the universal set, some values. Okay. So what are all the operations that I can perform on a set? The most general operation is union. That is, say here, there are 2 sets are there. X is there, Y is there. Union means I have to write all the elements of X and at the same time, all the elements of Y together. If there is any duplication, so no need to write only once you have to write that element, right? No need to duplicate the elements from X and Y. So in set builder notation, this can be represented like this. So this is the symbol for union. So X union Y, because X and Y are 2 sets, equal to X, such that, and that X must comes from capital X, or, this is very, very important, or the X must comes from Y. That is the meaning. So this is a pictorial representation, and this is the set builder form. Let us take an example. Let X equal to 1, 2, 3. I think in your schooling you come across with all these things, right? You can relate with data science, right? X equal to 1, 2, 3, 4, 5, and Y equal to 5, 6, 7, 8, 9. Then union. Just write down the element of X. 1, 2, 3, 4, 5. And here 5 is there. Already I have written. So no need to write 5. So 6, 7, 8, 9. That is the meaning of union of 2 sets. Similarly, intersection. Intersection means I have to write only the common elements, right? So that is represented by means of this symbol, right? X intersection Y is X such that X must be element of capital X and X should be the element of capital Y. Okay, so this overlapping area, shaded area, gives the X intersection Y. Similarly, let's have the element X and Y, the common element between X and Y, that is called intersection. That is 5. Okay. So another thing is disjoint set. Usually, dear participants, if you are going to take a data set to do some kind of analytics, right? Whether you are going to apply machine learning algorithms or deep learning algorithms, right? All the features should be disjoint in nature, right? So if it is some kind of duplication, if there is some kind of an overlapping, then surely your accuracy will be reduced. Okay. So now we will discuss the mathematics behind disjoint sets, right? So when I will say 2 sets are disjoint, right? Empty, then I can say these 2 sets are disjoint. See, X equal to 1, 2, 3, 4, and Y equal to 6, 7, 8, 9, and there is no commonality exists between X and Y, so the intersection is pi. So when X intersection Y is pi, then I can say these sets are disjoint in nature. And the next most important operation is difference operation. So the difference operation is represented by minus sign. That is, if I want to do difference from X minus Y, that means I have to write only the element of X. If the element of Y is there in X, I should not write. That is the meaning. right? A little bit it is confusing. It's very simple here. X minus y equal to x such that I have to write only the element of x. See, only the element of x. Only the element of x. If there is an element of y is there, I should not write. Right? That is the meaning of difference. See here, x equal to a, b, c, d, y equal to c, d, f. So x minus y means I have to write only the element of x. A, it's not here, so A. B, it's not here, so B. C, written here. D, it is also here, so I have not written. So the answer of x minus y is A comma B. Similarly, y minus z. C, yes, it is already there, I should not write. D, it's already there, I should not write. E and F, it's not there. So I am writing y minus x equal to E comma F. So this is called difference operations, right? And complement of a set. Complement means when a set is given, the complementation means you have to write the elements from the universal set. That's that thing I can say. See here, without the universal set, it is not possible to do complement of a set, right? So I can say where the complementation operation comes. Say for example, when a data set is given to you and there are some columns are not filled, right? Well, data generation, you are filling with some values, missing noise or missing values you are filling, that comes from some other area, that universal set. That is called complementation actually, right? We are doing only complementation, right? For filling the noise, right? Over in your data science actual data set, right? Say for example, how to do complementation. See here, I'm having X, C, D, E, F, right? If I want to do complementation, surely I have to know the meaning of universal set, right? So here, A, B, or comes under complementation because C, D, E, F are already there in X, right? So I think no need, it's a self-explanatory, the complementation. Okay, fine. So the next and last part with respect to set is Cartesian product. How to write a Cartesian product between two sets, right? The Cartesian product also gives the meaning called relation. It's another mathematical concept, right? So using the Cartesian product only, we are going to define relation. Okay, so now I explain Cartesian product, right? See here, there are two sets are there, X and Y. So if I am going to do Cartesian product, that is represented by a symbol called cross, right? So here the Cartesian product, I have to write the element in terms of pairs. See here, this is a pair, open parenthesis, closed parenthesis. It consists of two components, pair, A comma B, X comma Y, such that the first element must comes from the first set, the second element of the pair comes from the another set Y, sorry. See, in Cartesian product, I am going to write all the elements by means of pairs, such that the first element comes from the first set and the second element comes from the second set. That is the meaning. With an example, I will explain you. See here, there are two sets are there, X and Y, and X consists of A comma B and Y consists of C comma D. Now, the Cartesian product of X comma Y means I have to write the elements in terms of pairs. This is called the relation, right? How I return these pairs? That is A comma C, A comma D, B comma C, and B comma D. That's all the pairs. Similarly, Y cross X, C comma A, C comma or D comma A, next C comma B, then D comma B. So the first element, C, A, second set. That's all. This is called Cartesian product. So the Cartesian products only give the concept called relation. Okay. So in relation, there are several types. Reflexive relation is there, symmetry relation is there, transitive relation is there, partial ordering is there, hash diagrams are there. So many things are there with respect to set. And if you are going to do enormous amount of data analytics, surely these techniques will be highly useful in writing papers. Right. And these are all the sum of the fundamental properties of a set, right? That is idempotent property. That is A union A, always A. A intersection A, always A. Dominance law. That means, see here, if you are going to do union operation with universal set, then automatically the result would be what? Universal set only. If you are going to do intersection operation, so automatically the pi will be the result. That is the dominance, which is dominated here. Universal set with respect to union, which is dominated over intersection. Pi is dominated over intersection. And most important thing is associative law, distributive law, commutative law. I think everyone knows, because in your data set, if the data set is given, while splitting the data set and doing some computations, this associative law, commutative law, distributive law gives you a very nice pathway to improve your accuracy. That is A union B union C. This is also equal to A union B. Sorry. A union B union C is equal to A union B union C. Associative. Right? Similarly, identity law. A set is given and you are union with 5, then automatically we will get the set only. And if you are going to do a set is given A, and if you are going to do some intersection operation with universal set, surely you will get only A. That is called identity law. Similarly, commutative law, A union B equal to B union A intersection B equal to B intersection A. So these are all the very, very important laws with respect to set theory, right? So all the laws we are not going to use in any data science. Depending upon your problem, depending upon your application, you can use this law and you can give the results. So that's all with related to set theory. So I covered most of these things related to set theory. Kumar sir, is it audible?
Yes, sir. Proceed.
Thank you. So next I'm coming to the another part called functions, right? So again, when you take any machine learning problem, right? So it is defined by means of a function only, right? So that would be in the left hand side, I can say like that, y equal to f of x, that's all. If you ask me to define machine learning in terms of an equation, I can say like that, y equal to f of x. That is, y is my dependent variable and x is my independent variable. I have to find the value of f, that's all. It can be a classification problem, logistic regression, or it may be a regression problem, linear regression, right? So anything, and at the same time I can say y equal to f of x. And I can say my dependent variables and independent variables. The same thing, all this concept comes from this particular area, functions only. If you know clearly about functions, then you can do wonders with respect to fitting the regression equation, everything. Either it may be univariate, multivariate, like that. Okay. So now I am going to explain some fundamental things related to functions. Okay. So if you want to define function, surely there should be two sets will be there, right? So if you are going to do any kind of data analytics, surely there should be some independent variable and surely there should be some dependent variable, right? If it is a regression problem. Okay, fine. So likewise, leave the machine learning concept apart. Now I am going to focus only on pure mathematics, right? Related to functions. Let A and B be the two sets. Yes, I'm having the two sets, A and B. Now I am going to define a function. Function means a mapping, right? From A to B. That is mathematically defined like this. So a function, f colon, it's a mapping from A to B such that, what I'm saying here, there is an assignment of exactly one element of B to each element of A. That is mathematic definition, right? But if you pictorially, if you see this diagram, you will clearly understand what is actually a function is. See here, what I'm saying is, surely there should be two sets will be there, A and B. Now I am defining a function f from A to B, so that I have put arrow mark. When this function, this mapping, otherwise this relation I can say, this relation, when I will say it is a function, so if you see each element of B, each element, right, of B, there is an assignment with A. If it's there, then I can say it's a function. Exactly one. That is very, very important. See, let us take a point in B. Yes, it's having 1 point, mapping. Let us take a point. Yes, it's having a mapping. Only one. Only one. Only one. Only one. So it is a function. Why this diagram is, I am saying this relation f is not a function. See here, this point having a mapping with this point A, and at the same time the point B, which is also having some mapping. So since there is a relationship like this relation f is not a function, right? It is also possible some elements in B we can leave, right? That's not a problem. But once the mapping is defined, so some mapping should be there from A, exactly one mapping. So that is actually a function. Let us see some examples. See here, there are two sets are there, A and B. A consists of 1, 2, 3, and B consists of element A, B, C. I defined a function. The function definition is C. 1 is mapped to C, 2 is mapped to A, 3 is mapped to C. This is the function they define. And they are asking whether it is a function or not. See here, I have to go to B. C, it's having one element. A is also having one element. C is also having one element. Yes, f of 1, it gives C. F of 2, it gives A. F of 3, it gives C. So each element of A is assigned with an element of B. So f is a function. Yes. Let us take another example. A equal to 1, 2, 3, and B equal to A, B, C. See, now here I defined a function G in such a way. 1, C, 1, C. See, after discussing these two mapping, the element from A having two mapping. So it is not at all a function. G is not a function because G of 1 is assigned to C and B, right? So it is not a function. Once a function is given, so we have to know some of the preliminary things, right? What is domain? What is codomain? What is pre-image? What is image? Usually when a data set is given to you, they will ask you how you got these elements for this particular feature. What is its domain? What is its codomain? Everything you have to be, if you want to fix your career as a data science. All this mathematics is something more important. Now I am going to explain you what is domain, what is codomain, what is image, what is pre-image, right? At the same time, what is the range of a function? Everything I am going to define. See here, there is a set A and B. I defined a function f between A and B. So all the elements of A of a function f is called domain. All the element of the set of B of the function f is called codomain, right? And if there is a mapping is established, f of A equal to B, then I will say B is the image of A. And at the same time, I can say A is the pre-image of B. With respect to the function f, I will say range is the set of all images of the element of A. With an example, I will further clarify all these things. Let A equal to 1, 2, 3, B equal to A, B, C, and a function is defined like this. That is 1 to C, 2 to A, 3 to C. And they are asking what is the image of 1. Image means what is the mapping. So this is 1 is mapped to C. So the image of 1 is C. C is the image of 1. Okay. What is the pre-image of A? See here, pre-image of A is 2. Right, okay. 2 is the pre-image of A. And most important thing, what is domain of F? Domain means this is a function F. The first set, what are all the elements are there? That is domain. 1, 2, 3. So the domain of F is all the elements of A. 1, 2, and 3. Yes. What is a codomain of F? All the elements of the second set. Right? That is A, B, C. So the codomain of F is A, B, C. And what is the range of F? Range of F. So from this mapping, so 1 to C. So C is one thing. 2 to A. A is one image. And 3 to C, again C is coming. So A and C are the range of F. So if you are going to write all the images of F, it is called range. So that's all about all the preliminaries related to functions. Now we can go for some specialized functions called injective function, surjective function, and bijective function. Right? First I will explain what is meant by injective function. So injective function, otherwise called as one-to-one function, right? See here, I will go with an example so that it will give some better understanding. See here, There is a two sets A and B. I defined a relation F. When I will say the relation F is an injective function, see, if you see all the elements of A, there is an element mapping, exactly one element, right? So it's called one-to-one function. Otherwise, injective function. See here, this is not an injective function because see here, these two things is mapped to a same element. So this function F is not an injective. However, this function F is injective, right? Because only one assignment, one image is there, right? That is the meaning of injective function. With an example, A equal to 1, 2, 3 and B equal to A, B, C, I defined a function 1 to C, 2 to A, 3 to C. This is not one-to-one. See here, 1 is mapping with C and 3 is also mapping with C. So surely this function is not an one-to-one or injective function. However, let us see this function. I defined in terms of an equation, right? Linear equation. Let us see how to prove this kind of function as a injective function. See, I defined a function between integer to integer, all right? That is, g of x is represented by means of a linear equation 2x minus 1. How to prove this function as a one-to-one function, otherwise injective function? It is very simple. Substitute some variable to a, that is g of a. So for x, I am going to apply a. So 2a minus 1. Yes, 2a minus 1. Apply some other variable b. So it becomes 2b minus 1. So ultimately, right, this minus 1 get cancelled. So 2a equal to 2b, 2 get cancelled, a equal to b. Then automatically, when you are able to define this kind of an equality, right, then I can say that function is what? A one-to-one function or injective function. This is also the another way of proving, right, a function is a one-to-one or injective function. What is surjective function? A surjective function means R2 function, right? See here, all the elements of B has to be covered, right? That is called surjective. But see here in the previous example, some elements are missed, you know. So if there are some elements of missed, surely that function is not a surjective function. If all the codomains, I can say like this, if all the codomains values having some mapping, then I can say that is a surjective function. All codomains are covered. See, B is covered. 3 elements, all the elements of B are covered with A. So I can say it is a surjective function. And fine, this is some example. A equal to 1, 2, 3, B equal to A, B, C. There is a function defined. See here, C is defined, A is defined, but however, there is an element B which doesn't have any kind of mapping. So this function, F is not a surjective function. However, this function is surjective. See here, A equal to 0, 1, 2 up to 9 and B equal to 0, 1, 2. And they define a function. This is a modulus function, right? So whatever may be the elements that I'm going to take it from A. So 0 mod 3 is 0. 1 mod 3 is 1. 2 mod 3 is 2. 3 mod 3 is again 0. 4 mod 3 is 1. 5 mod 3 is 2. 6 mod 3 is 0. 7 mod 3 is 1. 8 mod 3 is 2. 9 mod 3 is 0. That's all. So all the elements of B is associated, right? So I can say this function is the function name H is a onto function, that is surjective function, right? So the final thing is bijective function. A function which is both one-to-one and onto, then it is called bijective function. See here, it is one-to-one and at the same time all the elements are covered. So I can say this function F is a bijective function, right? Let us see here, A equal to 1, 2, 3, B equal to A, B, C, and I defined a function F, right? 1 to C, 2 to A, 3 to B, all the elements of B are mapped. So I can say F is a bijective function. That means it is one-to-one as well as onto function. See, these are all the pure mathematics. But you can, once if you see the data set, because if you are going to do some data analytics, either you are going to apply machine learning or deep learning, you have to examine the data set. How you can examine the data sets? For that, you will do some lot of exploratory data analysis, EDA. Apart from that, you have to visualize the data. How to visualize the data? Through by means of all these mathematics only, dear. You can visualize the data. So once before going to do the analytics, you are having a strong foundation on analyzing the data itself, then surely you will clearly know which machine learning algorithm to apply to this particular data set, to that particular application, whether it is necessary to apply deep learning or not. So once while examining the data set with all this mathematics, right, you can clearly figure out which algorithm to use. That is an objective of all this, studying all this mathematics. Okay. The another component is composition of a function. Right. See here, this is very, very important for a data science, because when a data set is given to you, you will have several features. Right? If there is a transitivity is there with respect to your data set, then it is duplication is there in your data set. You can easily remove the duplication with the help of composition of a function. See here, first I will explain the mathematics behind composition. See here, there are three sets are there: A, B, C. And there is a mapping. F is a mapping from A to B. G is a function which is mapping from B to C. That is, see here, A to B, B to C. Then automatically it is not necessary to write B. We can directly write A to C because there is a mapping. No need to have this kind of feature B. That is the role of composition of function. Composition of function plays a very, very vital role in choosing the features. Which feature is actually necessary for doing analytics, right? Whenever this kind of transitivity is there, remove that commonality, right? So that automatically your dimension is get reduced, right? I think PCA do wonderful things with respect to dimensionality reduction. But anyhow, right, while doing some composition function with your data, you can easily find out without applying the PCA, right? You can find out the duplication of a feature which persists in your data set. Okay, if it is a high dimensional data. So that's all about the part 1. In this part 1, I covered elaborately the set, relation, and function. Now I'm moving to linear algebra. That is there is a core part of a data science professional. Kumar sir, can I proceed?
Yes, sir. Yes, continue.
Okay. So participant, if you are having any doubts, please note it down. So around 11:20, I will clarify all your doubts. Okay. Can I proceed? Anyone?
Sir.
Thank you. Thank you. So now I am going to focus on linear algebra. So I can say like this: linear algebra is a language, right, which provides a vocabulary visualization for the structure of your data set. Right? Once the data set is given to you, and if you know linear algebraic operations, right? And if you are able to apply the linear algebraic operation over the data set, then you can clearly understand the vocabulary of the given data set, right? So I can say like this, and you at the same time you can understand the real underlying structure of the data set that is given to you to your applications. So while applying these linear algebraic operations, so it is a very, very important thing. So in this linear algebra, so I request you to people to concentrate only on vectors and matrices, right? With respect to data science, because several things are there with respect to the field of linear algebra. But with respect to data science, we people have to concentrate on several mathematical principles related to matrices and vector space. That is the thing I am going to cover right now, right? So if you want to go for dimensionality reduction, then just applying the algebraic equations, we can right, reduce the feature. So once the number of features are reduced, then it is very easy for us to do some kind of computations, right? If there are a huge number of features, right, so ultimately achieving the accuracy is very difficult. That's why deep learning comes into picture. But for your data set, it is a countable number of features, then you can apply machine learning algorithms enough. It's not necessary to go to deep learning, right? That is an important thing. As a data scientist, you have to know all these kind of small things. Yes. What questions can be answered using if you ask these things? Sir, if I'm going to use linear algebra, so in what way it will be helpful in data science. Yes, solving a very large system of linear equations, right? So through some linear algebra only, you can solve very large system of linear equations, right? So if you people see the data set in terms of rows and columns, but I will see the data set in terms of only equations, right? So when all the numbers are given to me, I will see only in terms of equations. Very soon, I will also transform the knowledge how to view the data set in terms of equation to you after 20 minutes, right? And if you take any computer vision application, yes, the use of linear algebra plays a very, very vital role. And if you are going to do some good model design with using some machine learning algorithms like support vector machine, XGBoost, boosting, right, ensemble method, and if you are going to do some principal component analysis, and if you are with respect to unstructured data, vector space model or a word embedding. So for all these things, linear algebra plays a very, very vital role. And most importantly, if it is a deep learning is artificial neural network with dense networks, right? So a multi-layered neural network. How to optimize the weights, right? So there, linear algebra operation comes into picture, right? So whenever the optimization techniques plays a vital role, linear algebra provides solution to us. See, linear algebra. So now for another 20 minutes, I can say, I can touch upon linear algebra. If I am not able to cover linear algebra for about 20 minutes, I will continue the session in the afternoon from 2:30. Right? From 2:30, I will continue linear algebra along with statistics, probability, and chi-square test. Okay. First, let us see how a problem can be solved by using a linear algebra. For simplicity, I have taken this problem. This is an 8th standard math only, right? But once if you understand this 8th standard math, then only you can visualize the data set in terms of equations, right? So that is a thing. Right? So, my dear participant, I can say one thing. If you are going to fix your career, your elementary mathematics plays a very, very vital role. If you are very strong in 10th standard mathematics, that is 8th standard mathematics to 12th standard mathematics, then you can do wonders in data science. I can say like that, right? You should be very clear in fundamentals. That is very, very important, right? Okay, let us see how I am going to solve a problem by using a linear algebra, a real-time problem. Right? See, there is a problem is given to me, right? A ball and bat also given to me, and the number of units of ball and bat also given to me. So how I am converting this into an equation? It's very simple, dear, right? So suppose the price of the bat is X, I am fixing it X, and the price of the ball, I am fixing it as Y. And I am going to do some kind of purchase with respect to 1 ball, 2 bat. 1 ball, 2 bat. Right? So X plus 2Y equal to 100 units. Yes, simple. I transferred into equations. Similarly, the another thing is 2 ball, 1 bat. 2 ball, that is 2X. X is my ball. Sorry, X is my bat. 2X. 2X plus Y, 1 ball. So 100. So these are the 2 equations. So I have to solve these 2 equations to find the value of X and Y. X is the price of the bat and Y is the price of the ball. So if you want to find the X and Y, you will start multiplying something and your subtraction and but for data science people, we have to think like this, right? What are all the possible values are there which satisfy this equation? So what are all the possible values that satisfies the equation? What values I'm going to give it to X and Y in such a way it is equivalent to 100. So these are all the values. That is 50, 10. Sorry, 50, 0. See here. 50, if I'm going to give it to 50, that is 2 into 50 is 100 plus 0, it is equal. Okay. So from the equation 1, 50, 0. And 0, 100 also satisfies this equation. Yes, good. And next, 100 by 3 and 100 by 3, some fractional values, while substituting it, approximately is equal to 0. This is my third value. And 30, 40, which is also satisfy my equation. Sorry. That is 60. So if I am going to apply 30 here and 40 here, 60 plus 40, which is also 100. So 4 values, approximate values, satisfy equation number. So similarly, right, the other points, right, which satisfies the equation number 2. So I am going to draw by means of a line, right? And I want to find the intermediate, right, intersection. between these two lines. That gives the proper solution. The value of x and y. It's a one value. To visualize this problem, I'm not here solving this equation by multiplying, subtraction, not. I'm just visualizing everything. Because if it is a data science and if it is an equation, you have to visualize everything. Once if you're having the ability to visualize the problem, then surely you can do wonders in data science. It is my experience. Okay. So, broadly speaking, so you will be given with a data set. So, I said that data set means it consists of number of variables. What is number of variables? Number of variable means number of features, that is columns. Columns, I can say variables. And number of equations, number of equation means number of records, number of rows of values you will have, right? That is called, I can say it's a number of equation. While solving this number of equation, you can find the coefficients of all these variables, right? That is altogether solving the linear equation. For that, I am going to use vectors and matrices for solving these equations, right? Okay. If it is 2 dimension, 3 dimension, it is very easy. If it is more than 10,000 dimension, it is very difficult, That's why the matrices plays a very, very vital role in providing solution to this kind of problem. So that is the thing I am going to explain you one after the other, right? First, I will explain what is actually vector. So a vector is a real number, right? It's a column of n real number. That is a very, very important thing, right? We can say it is a column matrix like that, right? Okay. So a vector is r to the power n, that is a representation, is a column of n real numbers. See here, you are seeing V is a vector, which is having a column of values, column of real numbers, and each values are called component of the vector. That is -2 is the first component, 0 and 1. So normally a vector means it will have values and at the same time it will have direction, right? I will explain you. Here you are seeing only values, but if you ask me the question, sir, where is the direction? Wait a minute, I will show you the direction also, right? So what are all the operations I can do with vectors? I can do addition, I can do multiplications, right? These are all these two major operations, right? I can do it on the vector. See here I am seeing some directions to you. So 3, 1. See, it is in a coordinate geometry. I have going to represent the vector 3, 1, 0. That is, see, this is the blue line is a vector 3, 1. Now I think 3 and 1 you come to conclusion it's a value. But see the direction in coordinate geometry if I am going to draw this thing. 3 in y-axis 1. So this is the first vector 3, 1. So another 2, 1. So, sorry, 1, 2. So 1. Okay, this is 1 and 2, 1, 2. So this is another vector. So once the 2 vector is given to me, so I can do addition. That means, see here, the green is my new vector 4, 3. 4, 3. Right? So now you understand the value scalar, its value and its direction. Similarly, I can do some multiplication operation also. 2, 1. Yes, again 2 and 1. And I'm going to multiply with 2. So automatically it's moved to 4, 2. 2 into 2, 4 and 2 into 1. So the ultimate, the resultant 4, 2, this is the entire line. Right? So this is vector. So tomorrow I am going to do some case study analysis with respect to text analytics, where I will clearly explain the role of vector algebra, right? With an hands-on through R programming. Okay. Now I am going to explain you some of the from the basic level to the higher level, right? Mathematics related to matrices. Okay. Kumar sir, how much time I can take?
Yes, sir. Up to 11:25 you can take.
Okay. You please stop me, sir. You please stop me, sir.
Yes,
When 11:25 is reached. Okay.
yes, sir. Yes, sir.
Okay.
Yes, sir.
Then I will go for 5 minutes of question answer and I will continue the session in the afternoon. Okay, sir.
Yes,
Okay.
yes, yes.
Okay. Thank you very much. Thank you, participant. So, dear mathematics, I think you come across with this matrix from your 10th standard. So, I am going to talk about in and out of matrix, because ultimately, if you are going to see your data set, it is nothing but your matrix only. Either it may be a computer vision application, whether it may be a structured data application or unstructured, everything finally you are going to convert it into matrix. Otherwise, in Python language, I can say into a data frame. In a data frame only, you are going to do all these analytics, right? So you have to know the basic operations of that particular data frame that is called matrix. So that is the thing I am going to focus right now, right? So ultimately, if it is a deep neural networks, ultimately you are going to manage all the weights of all the neurons through by means of matrix only. Okay. So if you are going in machine learning, everything, finally you are going to train all the algorithms in terms of rows and columns, matrix only, right? That's why. So what is a matrix? A matrix is an array of numbers, obviously. Obviously, they will say a two-dimensional, right? That is row and column, right? See here, and the row, I will usually they will represent I rows and j columns, right? See here, how many rows are there? 1, 2, 3, 3 rows. How many columns? 1, 2, 3, 3 columns, right? If you want to pick out any particular element, you can use the index value I and j. That is, A is my name of the matrix, and A of I comma j is the corresponding location of that particular element in that matrix. See, if I am going to say A of 1 comma 2, that is first row, second column, that is 2. Okay. This is the matrix representation and how to access the element of the matrix. And these are all the various terms are there, right? Each has its own focus towards data science, right? That is order of a matrix. Order means number of rows and columns, right? Say for example, when a data set is given to you, if they ask what is the order of your data set, then you have to count this number of rows and columns. If the number of features are less, then it is a classical data. When the number of, when the number of columns are less, then it is a classical data. When the number of rows are greater than the columns, then it is called high dimensional data. When both rows and columns are infinity, right, more, then it is called big data. That's all. See, with the concept of order of matrix, I explained you the three most fundamental things for any data science people you have to understand. That is, what is classical data, what is high dimensional data, and what is big data. When I'm going to say a big data, when the rows and columns are approximate to infinity, then I can say it is a big data. When more number of rows are there compared to column, then it is called high dimensional data, right? When more features, when more features are there, then it is called high dimensional data, columns, and more rows are there compared to columns, then it is called classical data. Mostly you people work on classical data only. So it depends upon the application, right? Okay, fine. Sorry for the inconvenience caused, right? For 2 minutes. Okay. Then I will go with the square matrix. But usually we will never come with square matrix in our data science applications. Square matrix means the number of rows and columns must be equal, right? Usually it will never prevail in our real-time examples. Next is diagonal matrix. Diagonal matrix means a matrix with all non-diagonal elements are equal to 0. That means except diagonal, if all the elements are 0, then it is called diagonal matrix. Upper triangular matrix, that means surely the upper triangular means it's a diagonal matrix in such a way that all the elements below the diagonals are 0. That means we are having only the elements in the upper part of the matrix from the diagonal. Then it is called upper triangular matrix. Lower triangular matrix means we are going to have only the values in the lower part of the triangle with respect to the diagonal, right? That is called lower triangle. The remaining entries are what? 0. I will give examples for all these things very soon, right? Scalar matrix means a square matrix. Square matrix means number of rows and columns must be equal. In such a way, with all the diagonal elements are equal to some constant. See, if you see all the diagonal elements, it should be some constant value. 2, 2, 2, 2, if it is a 3 by 3 matrix. So that they have mentioned as a K, some constant, right? Then it is called scalar matrix. The most important thing is identity matrix. Identity matrix means all the diagonal elements, whatever may be the size, all diagonal elements should be equal to 1 and the remaining non-diagonal element must be equal to 0. Then matrix is called identity matrix. Column matrix, a matrix which consists only one column, right? That is called column matrix. Similarly, row matrix, a matrix consists of only of row. That is called row matrix. So a vector, I can say it is a column matrix, I can call it as a vector. It's an example of a vector is a column matrix. Then what is a trace of a matrix? It is the sum of all the diagonal element of a square matrix, right? When a square matrix is given, and if you are going to sum all the diagonals, then it is called trace of a matrix. So these are all the various concepts, right, related to matrix, right? Now I am going to discuss some of the well-known operations that can be done on a matrix. The first and foremost is arithmetic, right? See here, a matrix A is given. Let us consider this is a matrix A, which having the element Aij, I rows, and j columns. Similarly, having a matrix B, which having I rows and j columns. So the order of the matrix is m by n, that is m rows and n column matrix. See how to do summation. It's very simple. Take the corresponding I comma j of matrix A and I comma j of matrix B and just do summation. That's all. That is 1 comma 3, that is 4. 1 comma 4, that is 0 plus 4, that is 4. Minus 1 plus minus 1, that is minus 2. In similar way, right? I think it's a self-explanatory, right? Matrix addition. Similarly, matrix multiplication. But if you are going to do matrix multiplication, some property you have to remember. Say if A is a matrix is given whose order is m by k matrix, and B is a matrix which is given k by n. Once if the column of the first matrix is equal to the row of the second matrix, then only the matrix multiplication is possible. Otherwise, matrix multiplication is not possible. And the resultant matrix is m by n matrix. So that is the entire logic behind matrix multiplication. I will explain you with this example. Matrix multiplication, that is A equal to 1, 0, 4, 2, 1, 1, 3, 1, 1, 0, 0, 2, 2, and B is a matrix. It's a 3 by 2 matrix. This is 4 by 3 matrix. Yes, matrix multiplication is possible because it is 3 columns, 3 rows. It's possible. So the output is 4 rows, 2 columns. This is the resultant matrix. And how to do multiplication? This is the entire formulae, right, to perform matrix multiplication. See here, I have to take A11, this is the first one, B11, this is B11. I am going to do multiplication, 1 into 2, 2 plus summation. Next, 1 into 2, 2 plus 0 into 1, 0 plus 4 into 3, that is 12. That is 2 plus 12, answer is 14. So you have to take like this. Take the first row and multiply with the first column. You will get the 14. Take the second row, okay, multiply with the second column, right? You will get the corresponding things. I think it's self-explanatory, right? But the most important thing is matrix multiplication is distributive, matrix multiplication is associative, but matrix multiplication is not commutative. That is, A into B is not equal to B dot A, right? See here, A into B. So 1 into 2, 2 plus 1 into 2 plus 1 into 1, 1. So 2 plus 1, 3. Similarly, this one. 2 into 1, 2 plus 1 into 1, 1, it is 3. Yes, this value. So AB gives the value 3, 2, 5, 3. And similarly, BA gives the value 4, 3, 3, 2. Right? So it is clearly evident that AB is not equal to BA. So matrix multiplication is not a commutative property. Okay, fine. Next is identity matrix. I already told that the columns must be equal to 1. And the remaining entries must be 0. This is called upper triangle and this is called lower triangle. With respect to identity matrix, I am saying, right? And the most important operation that I can do with respect to matrix is transpose of a matrix, which is very, very useful to find out the parameter, right, of any regressor equation, right? Transpose. How to find the transpose is very simple. Just changing the rows into columns and columns into row. That's all. The transpose of a matrix. These are all the mathematics definition behind the identity matrix and transpose of a matrix. See here, how many rows are there? 2 rows are there. 3 columns are there. Just I am going to write first row as a column. 1, 2, 3 as a column. Second row, 4, 5, 6 as a column. That's all. The transpose is over. Right? This is the meaning of transpose of a matrix. Right? So now, with this, I think I can finish. Right? How to solve, right, an equation by using matrix. I think you come across with this 11th standard mathematics only. Very slowly, I will educate you how to solve all these things using any particular data science application. Right. See here, I have taken 3 equations. The equations are, let us see, this is the matrix value. This is the variable values. So here, how many variables are there? X, Y, and Z. And these are all the corresponding dependent variable. Z is my dependent variable. X is my independent variable. And A is my coefficient of all these variables. So if I want to write it in an equation, I can say like this. X plus Y plus Z equal to 1. This is my first equation. 2x plus y plus 0z equal to 1. This is my second equation. 5x plus 3y plus 2z equal to 4. So these are all my 3 equations. If you are going to make it as a data science problem, as a data set, so 3 features are there. For these 3 features, these are all the corresponding values. Like that, you can go with your interpretation. Right, how to solve, how to find the coefficient values, how to find the values of x, y, and z, right? Simple thing, I am going to solve using row echelon form, right? By using the concept of matrix. Let us first take the argument matrix of the given equation. Argument matrix construction means take the actual coefficient values of x and y, that is the matrix A, 1, 1, 1, 2, 1, 0, 5, 3, 2. And what is an augmentation? Augmentation means I have to write the dependent value also. That is 1, 1, 4. So now it becomes 3 by 4 matrix. So the initial matrix is 3 by 3. Now I am going to add 1 column vector. So now it becomes 3 by 4. So this is my 3 by 4 matrix. Now I am going to do some simple mathematics. I am going to multiply row 1 by 2 with 2. And I am going to subtract from 2. So what will come? Let us see. I am going to multiply row 1 by 2. So 2 into 1, 2. Minus 2, it became 0. So 2 into 1, 2, right? So 1 minus 2, minus 1. 0 minus minus 2, minus 2. 2 minus 2 minus 1, it is minus 1. Right? So that is the first operation. Multiplying row 1 with 2 and subtract from row 2. Subtract from row 2. Similarly, I am going to multiply equation 1 with 5. Equation 1 with 5. And I am going to subtract from row 5. See here. I am going to multiply row 1 with 5 and I am going to subtract from row 3. So 5 into 1, 5. 5 minus 5, 0. Next is I am going to multiply first row by 5, that is 5, 3, that is 3 minus 5, that is minus 2. 2 minus 5, that is minus 3. 4 minus 5, it is minus 1. That's all. Now, if you see closely, the lower triangle, if you see the lower triangle, right, all becomes 0. That means we are approaching to the solutions, right? See here. So next, with the upper triangle, I am going to do. I am going to have only the upper triangle. I have to make that. My objective is I have to make all the entries in the lower triangle to 0. That is my objective. So what I am going to do next time? I am going to multiply row 2 by 2 and then subtract from 3. While doing this operation, I will get this value. So ultimately, once if I received like this, all the lower triangle becomes 0, then ultimately I got the solution. That is, what is it? Z equal to 1. That is, this is the equation. That is third equation. That is 0x plus 0y plus z equal to 1. That is the equation. So this term becomes 0. This term becomes 0. That is z equal to 1. That's all. Now substitute z equal to 1 in row 2. That is having y minus y Now I got it z equal to 1. That is minus y plus minus 2 equal to minus 1. So for by substituting that 1, I will find out the value of y. Now I know the value of z and y, and substitute in equation 1, you will find the value of x. That's all. You can easily find out the value of x, y, and z. This kind of computation using the matrix for finding the values of x, y, z is called row echelon form. This is a basic things related to by using matrices how to find the values of x, y, z, right? But we are going to do with the inverse in data science. We are going to find all these weights through some inverse operation, right? So for finding the inverse, you have to do a lot of things, because see here, now I'm going to explain you what is called rank of a matrix. A rank of a matrix is equal to the maximum number of linearly dependent row vectors in a matrix. That is very, very important for a data science people. See, you are given a data set. First and foremost, you have to find what is the rank of that particular data set. If the rank, once the rank is determined, that shows how many independent rows are there. That is the role of the rank of a matrix. Okay. Okay. Yes. So that speaks a lot related to data science, right? So why I have to find out the inverse of the matrix? Let us see. So previously I solved these entire equations through by means of row echelon form. So once if you are able to find the inverse of the matrix with a very minimal computational things, I can easily find the values of the variables of the given linear equations. That is the role of inverse of the matrix. So in the afternoon, I will explain you once a matrix is given to us, how to calculate the inverse of a matrix, and using this inverse, how to find out the values of x, y, and z. And then I will take a real data set and how this real data set can be transformed to linear regression equation and how we are able to solve that particular linear regression equation. I will cover in the afternoon session, followed by what is the role of eigenvalues and eigenvectors. That is very, very important for feature reduction. That is what I can say, dimensionality reduction, eigenvalues and eigenvectors plays a very, very vital role, and how to find the eigenvectors and eigenvalues for a given data set. I will educate you. Then I will slowly move towards statistics and slowly towards probability. And then finally, I will conclude the session with chi-square test. Kumar sir?
Yes, sir. Yes.
So I think wait a minute. I will close my, I will stop my screen sharing now. Okay.
Manas.
Thank you, sir. It's a wonderful section, actually.
Okay.
Yes, sir. Sir, actually, you have covered the sets and functions and also linear, that is linear algebra. Most probably metrics, vectors, so many things you have covered. So participants, they are raising their hands. So you can ask questions directly to the sir. So you can have, if anyone have any queries, you can ask.
Manas, somebody raised a hand. Joseph.
Yes, sir. Joseph. Madam?
Joseph, madam, you can unmute and ask your question.
Madam, you can unmute and you can ask. And someone asked, Batmaja, madam, asked a good book for mathematics, right? Okay, surely at last I will suggest some of the books. Surely, if I'm going to list the books, I think you will not, once you go through the books and some of the concepts will be very tough and you will close the book. That is the thing, right? I will give all my presentation slides to you so that it will be a handy reference for you, madam. Surely, I will give you the list of books, madam.
Probably Indian authors, they are asking.
Okay. So any specific question, madam?
So, Sir, one question is there.
Yes. I am looking into the chat window, but
Sir, I have a question.
Yes,
Sir,
please,
this
please,
is
sir.
like
Sarkar.
Dhruva Stocker from MIT University, Kolkata.
Yes, please go ahead, sir.
Sir, my question is, or my basically that like this is a request. Although you have mentioned, sir, all those mathematical formulation, if you show us with an example application in basically data science, as you told that you'll be showing that the vector in text processing.
Yes,
So,
yes,
sir,
yes.
we'd like to request you that, sir, in those cases, it will be easier for us to correlate and then to think in that direction also.
Okay, excellent, sir. That's why Kumar sir given me 3 sessions to me. First, I will cover all the core mathematics. Finally, I will take a case study and I will correlate what actually the vectors in mathematics plays a vital role in solving that particular data science problem. Okay, sir. That is a cosine similarity. And at the same time, I will give you some kind of an hands-on also, sir, with respect to our environment. Okay.
Right.
Surely, tomorrow morning we will have that kind of case study, sir. First, I will cover all the mathematics.
Excellent. Sir, the session was excellent, and while you were discussing the vector or basically the matrix at that point of time, as I know basically VSM vector space model, so I could relate the concept there.
Yes,
so I think that if you discuss in that direction, definitely that will be excellent for us.
Surely, sir. Surely, I will explain you all these things. Very soon in the afternoon session itself, I will explain you by taking a data set and how to form into a regress equation, right? And in the regression equation, how to find out the parameter value. There, what is the role of matrix and its inverse. Everything I will explain you in the afternoon, sir. Okay. Sarkar sir, is it okay? Where I am audible? Kumar sir?
Yes, sir. Yes, sir. Yes, sir. It's absolutely okay.
Thank you.
Sir, one more question from participant.
Yes, sir.
Which software is good as mathematical point of view in data science? Some Vinay Kumar sir is asking that.
Which software is good as mathematical point of view in data science? I'm not able to understand whether, say for example, I can say like this. If it is statistics, please rely on R programming, right? So there are a lot of packages are there with respect to R platform, right? Compared to Python. But if you are going to do with respect to data science alone, right, with the minimal level of statistics, then you can rely on Python, right? Okay. Is it okay? But being a data science professional, please focus on R and Python. Even you can do all these stuffs in MATLAB also, right? So 3 things I will suggest you, sir. If you really want to do some good things with respect to visualization, please concentrate your things with respect to Tableau, right? And with respect to core programming, you please concentrate with respect to MATLAB, R, and Python programming.
Okay,
Julia is also good. Julia is also good.
Yes, sir. Yes, sir.
But nowadays,
if anyone have any further questions,
but nowadays people are morely focusing towards Python only. I don't know why. I think Kumar sir will give some better idea why people are moving towards only Python.
Sir, every time one language is
because the community is a very nice community, Python, because they are vibrant community.
Yeah, it is a common to all. That's
yes. Being open source, everything. R is also open source, but Python is speaking, going like anything.
Almost all domains using Python.
Yes.
That's
I think I satisfied all the participants, right, with respect to the first part of my lecture. Surely, I think I will give some other things in my second session too. In tomorrow morning, I will give you the application point of view. I will relate all the mathematics that I discussed today tomorrow with an application. As Sarkar sir said, I will correlate everything.
Okay, thank you, sir.
Okay.
If there is no further queries, we can wind up the session.
Okay, sir. Thank you. Kumar sir?
Thank you. We will meet 2:30 again.
Sir, 2:30 I have to join. Is it correct,
Yes,
sir?
Yes.
So, okay, dear participant, I will resume at the time of 2:30. Thank you for your kind cooperation. Thank you very much.